just a minor announcement. I don't know if either one of you are interested, but this coming Friday, day after tomorrow, there will be a presentation on the Birmingham East Campus at the A.G. Gaston building of Shakespeare's Taming of the Shrew. Okay, it was a comedy, and this is being performed by UAB Theater Department. And it's a little bit different take. These local things like to change things some. Shakespeare's Taming of the Shrew is a classic. They even made a movie out of it, you know, so it's quite a long formula, you know, classic comedy. And the story of it was the woman was very difficult, strong-willed, strong-minded, and the guy was trying to tame the shrew, okay? Well, UAB has decided, or whoever wrote this rendition of it has decided, let's reverse the roles and have the man being very difficult, very strong-willed, strong-minded, and the woman trying to tame him. It's supposed to be just about as funny. I'm not sure they can improve on Shakespeare, but they're trying. So it would be a nice thing to do if you're interested. You might check, someone asked this in my last class, if you're in a English or humanities class, you probably won't be able to get it, but if you are in one, you might be able to get extra points for going to it, okay? It's Friday, 10 o'clock in the morning, Birmingham East Campus, A.G. Gaston building. Okay. Now, other things. My office hours today should be 3:15 to 5:15. However, my car is in the shop, okay? So I'm going to have to leave sometime. I'm going to call the shop at 3:15 to see if it's ready. If it is, then I've got to find a way to get there and go pick it up and unfortunately pay for it. But I also need to take it at some point to the Birmingham East Campus for someone to give me an estimate on something. So I don't know for sure if I'm going to be coming back to this campus or going to the Birmingham campus. But so today's office hours are kind of up in the air until I see how things go. Okay. But rest of the time, now Friday, normally I'm on the Birmingham campus. I should be there. Normally I have office hours 7:45 to 11:45. As far as I know, I will. I may be going to Taming of the Shrew at 10. I don't know. I'm really not. I have other things I need to do, but if they need people to go, I may go to it. And we may have a meeting on Friday, but usually the meeting that comes up the fourth Friday is usually in the afternoon, so I don't know for sure if that's going to happen or not. But it shouldn't interfere too much with office hours. Taming of the Shrew might, but that would be the only thing. All right. Any questions on what we? What is your sweatshirt?
Birmingham. We played them last year.
Oh, I see.
We played them last year out to Boston, and some guy left his whole bag. Like gloves, shoes, everything, and they can come back the rest of the year. So at the end of the year, I just take it.
Oh, really? Okay.
It fits good.
Yeah. Yeah, the colors are right for Georgia Tech, but I knew that wasn't saying Georgia Tech, but I was going to say if it was, you get an extra point. Too late now, okay. All right, no, I'm just kidding. I wouldn't have given you extra point. Okay, you should know better than that by now. All right, so we'll start from current slide. Really? Okay, no questions on campus stuff or calculus stuff? Ready to go? Okay. This isn't example 4, but it's this slide we'll use to do example 4. Here is the integration we're called to do in example 4. Whoops. Got to get my pen set up. Okay. Integrate x cubed plus 1 over x squared minus 4 dx. How do you approach that problem? Decide carefully. Say again? Okay. It's not quite a perfect square. However, it's not a bad thing. It's the difference of two perfect squares. Is that what you meant, the denominator? That's certainly going to be part of the problem, so let's recognize that right off the top. And that would be, what is it? X plus 2 times x minus 2. Okay, that is a good thing to note. So we will, from now on, write the denominator that way, almost. Don't do something else first. Okay, what else do you notice here? Anything in particular? Pretty exciting stuff, isn't it? Okay. What's that? It's improper, meaning we do what? We can only do our partial fractions if the numerator's degree is less than the degree of the denominator. Not the case here. So how do we make that happen? What if we, name me an improper fraction. Make up one. 4 over 3. Okay, excellent example. 4 over 3. How do we make that so at least part of it is a proper fraction? Yeah, divide 3 into 4, and how many times will that go? 1. And how many left over? 1/3. You have just made that into a whole number plus a proper fraction, right? And what did you do to get there? Divide. So guess what we might do over here? Divide. Let's do that. Okay, divide and conquer. Okay, so we'll go back to our original form. X squared. Now here's a problem, Houston. Okay, remember that? Okay, you need to account for every term. So we're going to put x squared plus 0x minus 4. You have to have every term accounted for. Divided into, you tell me what to write. All right, okay. X squared. Plus 0x plus 1. Very good. You have to account for every term, especially in the divisor. I think it's a good idea, the dividend. It's a good idea to do it in the divisor as well, but you've got to do it in the dividend. Every term. Make sure you have every term accounted for. All right, so let's start our division. And by the way, could we have done synthetic division on this one? You may not remember how to do synthetic division, but could we have done it if you had remembered?
Possibly.
No. Okay, and here's why. In order to do synthetic division, the divisor must have a coefficient of 1. We got it, but also an exponent of 1. We don't got it. Okay, so this one has to be done long division. Okay, so what do we do first? And what does that give you? Very good. That's what that funny little house stands for, okay?
Oh, it doesn't go into x3, so now we gotta go to x2.
Wait. X squared will go into x cubed.
1 time.
Nope.
2 times.
Nope.
1/3 times.
Nope. Hi. Okay, never mind. Okay. How many times will x squared go into x cubed?
No, 0?
Ah.
I don't know.
Any guess? Want to go x times?
That's what I'm saying.
Oh, I'm sorry. I thought you said one time. Okay. Silly ears. I just don't hear well. Okay. Now what do we do? Multiply. Will it multiply?
Multiply x by x squared.
And what do you get? X cubed. It does work, doesn't it?
Plus x squared.
Huh?
Plus 0.
0x squared
Minus 4x.
minus 4x. Okay, then what do we do? Change signs and add. Blank. Doesn't matter about that sign. That. Okay? These add to 0. Right? That one was 0, stays 0. This one becomes 4x. Next,
Plus 1.
bring down the 1. Okay? And then, will x squared go into 4x? No. We are done. Now your remainder has a lower degree than your divisor. You're done. Okay? So, what we write here is plus your remainder, 4x plus 1 over your divisor, x squared minus 4. Okay? So let's go back and change our integral to be the integral of the quotient, x dx, plus the integral of your remainder, 4x plus 1 over, and now we're going to do what Bailey said to do, factor that denominator, x plus 2 times x minus 2 dx. Okay. Now, I'm convinced, sucker that I am, that you can do that first integration. Prove me right. What's that? The pressure's on. Say again? X squared over 2. Perfect. X squared over 2. Okay? Now, how do we proceed with the next part?
Yeah, do all that stuff.
Second?
All that stuff.
All that stuff, of course. Why didn't I think of that? Okay.
Like A1, A2.
All right. Y'all like those A1s and A2s, okay? So we'll say that 4x plus 1 over x plus 2 times x minus 2, am I getting all this stuff right, is equal to, you tell me what to write, A1 did you say, over x plus 2 plus A2 over x minus 2. Okay? Okay, multiply that denominator by everything in the numerator. Multiply the least common denominator, which will be x plus 2 times x minus 2. This will be times x plus 2 times x minus 2. And this will be times x plus 2 times x minus 2. Okay? And on the left-hand side, the x plus 2's go out and the x minus 2's go out. You're just left with 4x plus 1 equal to, in the first term on the right, what happens? The what? The what? X plus 2 divide away. What are you left with? A1 times x minus 2. Okay, let's leave it like that, right? Plus, and then on the right-hand side, the right term, the x minus 2's go out, and you're left with A2 times x plus 2. Okay? Now this is what the equation we're going to use now, and where do we go from here? Okay, we'll start with saying x equal 2. Let x equal 2. What does the left-hand side become then? 9 is equal to? Second? Okay, A2 times what? 4. 4A2. What does that produce A2 to be? 9/4. Very good. Okay. Now, I don't have a lot of room, so what I think I'm going to do is start erasing some stuff. Sorry about this. I'm going to erase my long division. I know y'all love it, but you should have it down already. I'll even erase your 4/3, okay? I know that was really important to you. I hope I didn't erase something I shouldn't have there, but anyway. All right. Let's do the second part. Go back to this equation here, the linear equation, and what do we do now? X equal -2, is that what you said? Okay. And the left-hand side becomes? One more time. -7, all right, is equal to, first term on the right becomes? Second? -4A1. And the second becomes? Okay, yeah. The second becomes 0 because when x equals -2, that goes to 0. So now your A1 is equal to, what did you say, 7/4? All right. So, picking up where we left off here, just this second integral here now becomes the integral of your A1 is, I'm going to put the 7/4 on the outside because it's just a constant. And you have 7/4 times dx over x plus 2. Okay, where I'm going here, I'm plugging that A1 into this. The original thing we had, A1 over x plus 2. Your A1 is now 7/4 over x plus 2. So that's just going to be dx of x. And the second part is going to be plus, when you do this part here, what would that become? You're integrating, second, 9/4 integral of x minus 2. Very good. Okay. I think I don't need the stuff down here anymore, so I'm going to erase it, if that's okay. Can I? Okay. I don't think I need any of this anymore. I wish I could just draw a line and say erase everything below that. Unfortunately, this is not a very smart package, nor is it a smart operator either. So. Okay. All right, finally. Plus, and what's that first integral? Change this to that. So the first integral is what? 7/4. natural log of absolute value of x plus 2 help me plus 9/4 the natural log of absolute value x minus 2. And then somewhere out here we need a c. Okay? Now, this is one potential answer. It's a perfectly correct answer. Okay? Another thing you could have done was written this as the natural log of x plus 2 to the 7/4 power plus the natural log of x minus 2 to the 9/4 power. Okay? And you could combine those two to be the natural log of x plus 2 to the 7/4 times x minus 2 to the 9/4, absolute value. Okay? Okay, and then left the plus c. Or, way back at the beginning, you could have made that a log c, natural log of c, and then that gets multiplied by, and it would be natural log of c times x plus 4, x plus 2 to the 7/4 plus times x minus 2 to the 9/4. But guess what? Why do all that? This is a perfectly fine answer. Let's see if it's what the book did. Oh, here we go. 1/2 x squared, they wrote it as that, okay? And guess what? In your WebAssign and other kind of computerized packets, if they'd have wanted a 1/2 x squared, they would have count x squared over 2 wrong with it. Exactly a correct answer. Plus 9/4 natural log of x minus 2, absolute value. In fact, the order they may have not even recognized, okay? Plus 7/4 times the natural log of x plus 2 plus c, yes. You don't have to have it looking exactly the same, but in those packages, use better, or else it tells you it's wrong. What's that?
They're expensive.
I can't hear you.
WebAssign.
What about it?
It's expensive.
Is it expensive?
Yeah. It's like I had it for free now, and I had to pay like $80 just for the access.
You had to pay $80 for the access, and did you find it helpful?
No. It actually made my grade go lower. I have it for physics right now, and it doesn't help at all. It's just a pain in the butt, really.
That's been my impression, but I don't like to poison students about it, but it really is enheartening to me for you to tell me this kind of stuff. Because
Mr. Rossi, we had to do it with her. I had both semesters, pre-cal and calculus 1 with her.
Right.
But in cal 1, we got to choose not to put that on final grade.
Okay.
It was just, it's so hard to keep up with. And hers, there would be like 40 problems, and it's like, I can't do it every night.
Right.
And like you said, like you would get it right, and they would be wrong. So it was just annoying.
That to me is so frustrating, because I hate for students to be doing something right, be told it's wrong, then they think their whole process is wrong. To me, that's counterproductive. It makes it a bad experience,
I did a problem last night, and it was something like, it was a physics problem, and the answer was like 3.66, and I put 3.7, just rounded it, and it said it was wrong, and I was like, let me just check, and I put 3.66, because it was like 66666, and it said that it was right, but I mean, I just let it was rounded.
Yeah. Well, actually, if they wanted 3 digits, it should have been 3.67.
Yeah.
It shouldn't have been 3.66. But yeah. See, their answer was wrong.
That one in chemistry, we will all get groups of friends, and we start doing our chemistry homework on the Connect one, and sometimes we have the same problems, but for some reason, 2 of us would get the problem right, and the other 2, the system said it was wrong, and so they had to round it, but we
Oh, really?
Yeah, it was like glitches.
You wonder why I don't like that package? Because students come, to the instructor and say, I don't understand what's wrong. And I have to look at it and say, well, actually, nothing's wrong. You got it right. The system's wrong, or the system's just looking for a different form. But how much pain and anguish do you go through before you reach that? It's not worth it in my mind. But anyway, that's my little soapbox. So I got to get off of it. Okay. Now, the next subtopic here in this section is quadratic factors. A quadratic polynomial of this form, ax squared plus bx plus c. Okay? We're used to that, right? What do we mean if we say that is irreducible? What does that mean to you? Anything?
Can't be reduced.
It's what?
Can't be reduced.
And what do you mean by that? It's what? It's in what form?
Simple.
Okay. It's in the simplest form you can get it. In other words, you can't factor it. Okay? That's what it means to be irreducible. It can't be reduced to a pair of simple factors. It's non-factorable. Okay? If it cannot be written as a product of two linear factors without using complex numbers. Okay? So wait, hold off a minute. Okay? That's not quite the same thing we mean by can't be factored. Usually by factoring we mean with integral coefficients. Okay? This allows us to have radical coefficients. No complex coefficients, but radical coefficients. So that's the only little difference between it can't be factored or and irreducible. Irreducible does allow, it can be reduced if you have radical factors. That would be perfectly okay. So the only thing we're excluding now are complex numbers. A power of an irreducible quadratic factor, if you raise that to a certain power m, like raise this to some other power m, okay, contributes to the sum of the following type to a partial fraction decomposition. Okay, boy, they jump right in and give you just about the most difficult kind of example you could have. Okay? If you have an irreducible form, now that doesn't mean it can't be factored. That's part of it. But it can't be factored even using radicals. That's what we mean by irreducible. Okay? So if you cannot factor this without having complex numbers in it, that means irreducible. Then if it ends in this form, you start with this. Remember, if you had x minus a to the 7th power, what would be your breakdown of that in your partial fractions? Remember how that would go? You'd have a over, or we can call it a1 over x minus a plus a2 over x minus a squared plus a3 over x minus a cubed, and you keep on going till you get up to a7 over x minus a7. That's how you would do it if you had linear factors. Anytime you had a multiplicity, you have to include the first, second, up to whatever your multiplicity was. In this case, 7. This case with m, if that quadratic is irreducible, you can't factor it with integers, you can't factor it with rational numbers. If it's irreducible, the only way you could factor it would be complex numbers. Don't do that, that's irreducible. Then your factors would be, okay, a1x plus b1 over ax squared plus bx plus c. And again, the a's and b's have nothing to do with capital and little. They just use the same letters. Why, I don't know. Plus a2x plus b2, a different linear numerator, over ax squared plus bx plus c squared, plus a3x plus b3 over a squared ax squared. I'm getting ahead of myself here. Ax squared plus bx plus c cubed plus dot 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 all the way up to m x plus b m sub m over ax squared plus bx plus c to the nth power. Okay? That's what you do. If you have that raised to, if that's in the denominator, and it's to the nth power, then the terms that break that down are to the ax plus b over that's the first, another ax plus b, a2, b2 over the second, third, fourth, fifth, up here. All these a's and b's are different, so they may be. Okay? We just keep them that solution. So, now let's say here, here's an example. So let's clear this out of the way so we can do an example. Okay? What if you had 4 minus 12x? By the way, it doesn't have to be, the numerator doesn't have to be written in descending order. Okay? Doesn't matter. And here we have an x plus 1 times an x squared plus x plus 4 squared plus x plus 4, but that's to the second power. Now, I want you to see if you can factor that second, that quadratic term. Think you can? Probably not. You can't. Okay. The next thing we would try would be what? If you can't factor it, we would try the quadratic formula. And how would that go? X is equal to minus b, which in this case would be minus 1, plus or minus the square root of, no, b squared. Okay, let's go back and write it down. Okay, x equal minus b plus or minus the square root of b squared minus 4ac all over 2a. Remember it? Okay, so this would be 1 minus 4 times 1 times 4 over 2. Time out. Okay? When you're doing this, first thing to look for is that discriminant. Okay? Now, the first thing I look for in the discriminant is counting my number of minus signs. Here. 1. Plus, plus. Only 1. That means this is going to be negative. So this is going to be a negative 16. That's the 1 minus 16 is minus 15. Not factorable, not that's irreducible, because that would involve i's, imaginary numbers. That's when you know, nope, can't reduce that any further. If that would have been a plus 16, yeah, square root of 17, you can't factor it, but you can write it as x plus 1 plus square root of 17 over 2, and x 1 minus the square root of 17 over 2. You can write it awkwardly, but you can write it with 2 factors. That is reducible. This one is not, because that has an I in it. It would produce an I. So, that's how we tell. See if you can factor first. If you can't factor, use the quadratic formula. If the yuck! I just hit the wrong key. Okay. So let's go back and write down what we had before. 4 minus 12x over x plus 1 times x squared plus x plus 4 squared. Okay? So what would be your breakdown of this? You say just go a over x plus 1. That's a good start. Plus, I can do the plus. Okay. It doesn't matter. That'll come out into A's and B's. Usually put down pluses. Okay? That's why I say I'll put down plus. You're looking at the book, aren't you? Yeah, okay. I'm doing it the step before you got to where it is in the book. Okay? What would go next? Okay, why not? B is over a quadratic form, right? Your numerator is always 1 degree less than the denominator. So that's going to be a bx plus c. That's quadratic down there. Make this linear up here. Okay? Over x squared plus x plus 4. To what power? First. Yes, right. Are you through? New. What do you do next? Dx plus e over, second, x squared plus x plus 4, this time to the second power. That's what you do. Yes, yes, yes. Okay? And what do you do at this point? Yes! Multiply by your least common denominator. What is your least common denominator? That first one right there. Right? So that's times x plus 1 times x squared plus x plus 4 squared. Okay? And the next term you multiply by x plus 1 times x squared plus 4x plus 1, plus x plus 4 squared. And the next term you multiply by x plus 1 times x squared plus x plus 4 squared. And the last term you multiply by x plus 1 times x squared plus x plus 4 squared. Now we eliminate what we can. Over on the left, x plus 1's go away, and your whole thing go away. You're only left with a 4 minus 12x. Thank you very much. Okay, first term on the right, only the x plus 1's go. So you're left with a times x squared plus x plus 4 squared. Doesn't look promising, does it? The second term is a bx plus c times, and here, one of the x squared plus x plus 4 go, but everything else is left, so that's times x plus 1 times x squared plus x plus 4. Not squared, because you got rid of one of them. And on the last one, the x squared plus 4 plus x plus 4 squared goes out, and you're left with, I'm running out of room, plus dx plus e times x plus 1. That's it, right? Yeah. Sorry, I have to write underneath there. All right, so what would be your first thing to do? Pretty exciting, isn't it? Yeah, I can tell. Me too. X equals -1. We can't do it for all of them, but we can do it for that. Okay? And if x is equal to -1, what does the left-hand side become? 16 tons, and what do you get? Another day older and deeper in debt. Okay, never mind. All right. What does the first term here give you? Okay, okay. You got a 1 from here, plus a -1 is 0, plus 4 squared is 16/8. Very nice. Okay. Plus 0 and 0. That's all right. Okay. So what is your A? 1. Wish they'd all be that easy, don't you? Okay, there's nothing else we can do to just plug in anything. Okay? So where we're left to do now is multiply everything. Okay? Well, except we know that A is equal to 1. So let's write down that anyway. 4 minus 12x is equal to x squared plus x plus 4 squared, because A is 1, plus, oh my goodness. Okay? Now, how do you want to do it? It doesn't matter to me. You could first multiply these two and then multiply that by that, or multiply these two first and multiply that by that. Pay your money, take your choice. You've already paid your money. What you choose. You have a preference.
What were the options?
It's just an associative property of multiplication. You can either multiply these two first, multiply that, and go there, or multiply these two first, multiply that, and go that. Don't be messy either way. It's just whichever mess you want to do.
Let's do x plus 1 times x squared plus x.
This first. Okay, we can do that. All right. All right. I'm going to do it down here, and I'll probably erase what I've got. So this will be a bx plus c, just so I don't forget that, times this. Okay? I'm going to do first term first. X times x squared is x cubed, right? Now, what I'm going to do next, this is just my way of doing it, I'm not saying you have to, but I want to do x squared next. That's the only x cubed you're going to get out of this, right? Okay, so the x squareds are going to come from these two and those two, right? That's all the x squareds you're going to get, right? So that's going to be plus x squared, plus x squared, so that's plus 2x squared. By that, okay? Say that again. You what? You got the answer? Am I doing it right so far? Okay, good. Okay. Now, I just wondering. You don't have to do it this way. If you can do it real fast, you can do it, okay? Next, I want the x terms. Now, the only x terms I'm going to get are from here and there. So that's 4x plus x is 5x, right? Okay? So that'll be plus 5x. And then the only constant term we're going to get is plus 4, right? Is that what you got?
Yeah, I did the same way.
You what?
I think I did the same way.
You did? Okay. All right. So, yeah. You were thinking ahead of me, okay? Is that okay? Do you mind that way? You can string it out if you want to other ways, but to me that's the easiest. Okay, now we got to multiply those together. So we're going to kind of do the same thing, only different, okay? I'm going to put parentheses there. I was going to do it somewhat differently, but I thought y'all are advanced, you can do this. Let's write down the biggest term is going to be our x fourth, and you're only going to have one of them, right? And that's going to be plus bx fourth, right? Bx to the fourth. By that? All right. Now we're going to have our x cubed terms. Let's go from two sources. This source plus 2bx cubed plus cx cubed, right? So that's 2b plus c x cubed. Is that what you get? You get that? Okay? Everybody see it? All right. Now your x squared terms. You're going to get an x squared term from here and an x squared term from there. So this is going to be 2c plus 5b x squared, right? So I think I'll write it 5b plus 2c. 5b plus 2c x squared. Okay? Now our linear terms. We're going to have two of those. 4b plus 5c, right? So plus 4b plus 5c x. Right? And then our last is going to be plus 9c. Isn't it? I can't read it. Okay, yeah. That's a 4, you're right. Thank you. Y'all are good. Okay, plus 4c. Got it. My writing stinks. Okay. Now that's just that term. Okay? We still got this term to go. But fortunately, that's going to be a little bit easier, right? That's just two binomials. So just FOIL that. Dx squared. You see it? Plus dx squared plus d plus ex plus d plus e x plus e. Okay? Now we'd be smack dab ready to go if we didn't have that first squared there. We really need to do that one too, right? So that's basically x squared plus x plus 4 times x squared plus x plus 4, right? You buy that? Okay. Now, if you multiply those together, you're going to get an x fourth term, right? X to the fourth. That's those two, right? Now, we're going to get two x cubed terms, right? Plus x cubed plus x cubed. So that's plus 2x cubed. You see that? Okay. Now, x squared terms. Whoa. Be careful here. You got 4x squared plus x squared plus another 4x squared, right? So that's going to be 9x squared, isn't it? Okay, so you got 9x squared. Okay, now linear terms. I only see two of these, 4x plus 4x. So that's going to be plus 8x. You buy that? And then you only have one constant term, and that's plus 16, right? All right. I'm in serious need of more space. Okay. So let's just combine all this together, and that replaces this, right? Now, there's a couple of ways to begin here, and I really don't care how you begin. I kind of like to start with the biggest power. Do you have any objection to that? I like power. Okay. So x4 terms. How many x4 terms do you have over here? None. So you have a 0 coefficient for x4. How many x4 terms do you have over here? All this. Just these two, right? So that gives us 1 plus b is equal to 0. So guess what b is? Guess what b is? No. Okay. Here we have a 0 over here for x4. Here you have a 1 plus b. Those are your only two x4 terms over here. So 1 plus b is equal to 0. I wrote that down here. So what's b equal to? -1. All right, good. So b is -1. So a is 1, b is equal to -1. Okay? Good. Let's go to the cube terms. What cube terms do you have over here? None. So you got 0 again here. Now let's do our cube terms here. All right. You got 2b plus c. Oh, wait, here's one. Here's one. 2 plus 2b plus c. Those are all the cube terms, right? All right, so let's write that down. What do I say? 2 plus 2, but b is what? -1, right? So that 2b would be -2, right? 2 minus 2, right? Did I do it right? Plus c is equal to 0. Okay, let's see where we got this. 2 plus, and b is -1, so that would be -2. 2 minus 2 plus c is equal to 0. So 2 minus 2 is 0. So guess what? C is equal to 0. All right. So there we have that one. All right. A is equal to 1, B is equal to -1, C is equal to 0. All right. Let's go to our squared terms. What's your squared term here? Huh? 0. Okay. So you got 0 for squared. Here we have a 9 minus 5, right? Because b is -1. So 9 minus 5, that would be 4. Plus 0, so you still got 4. Plus d, right? Did I do it right? 4 plus D equals 0. Did I do that right? Let's check it. Square term. 9 minus 5 is 4 plus 0 plus D. So 4 plus D is equal to 0. So what would D have to be? Negative 4. So D is negative 4. So D is equal to negative 4. Is this crowded enough or what? Okay. I think what I'm going to do is erase some of this. Is that okay? Like, I don't need this anymore. I don't need that anymore. I don't need this anymore. Okay. I probably don't need these anymore either. I don't know what that was that I just did. Oh, I know what it was. Okay. All right. Got it. All right, let's go to the linear term. What's your linear coefficient here? Negative 12. Lovely. You can call that right off the bat there. Okay. So negative 12 is equal to 8 minus 4 plus 0. So 8 minus 4 would be 4. Minus 4, that would be 0. Plus E. So I think it's just E. Minus 12 is equal to E. Is that right? E is equal to minus 12. Okay, let's go back and make sure I did it right. Minus 12 is here, that's on the left. And here you have 8. Minus 4, that would be 4. Plus 0, so that would be 4. Minus 4, that would be 0 plus E. Yeah, I think E is equal to minus 12, isn't it? Sure seems like it. All right, what's your constant term on the left? What's your constant term? 12x is a linear term. What's the constant term? 4. Okay, 4 is here. What's your constant term here? 16. Okay. Plus 4c, but c was 0, so it's still just 16. Plus e is minus 12. So 16 minus 12 is 4. 4. Ah, that's just this check for you. Yes, 4 is equal to 4. If that hadn't come out right, you probably did something wrong. So guess what, folks? We got what we need. A, B, C, D, and E. Okay? So, I'm going to start erasing some stuff, and I sure hope I don't erase too much. I don't think I need this anymore. I sure hope not. Okay? It won't erase very fast. So I think I'll just stop right there and try to write it all in here. Okay. So what we have, this, remember, was our integral. Remember? This part on the right before we did all the crossing out. That was our integral, right? Yes? Okay. Now, what is your A? 1. So this integral is 1 over x plus 1 plus, and what's your B? It's a minus 1, so let's just change that to a minus. X over x squared plus x plus 4, because C was 0, right? okay? Plus your D was a -4, and your E is a -12, so it looks like that should be a minus, and it sure is, I think. Okay. That would be D was -4x, and E was -12. So I'm pulling the minus on the outside, so that would be 12 over x squared plus x plus 4 squared. And lo and behold, that's what they got, didn't they? Well, that's just that part of it. Okay. They didn't set this up as an integral. I'm sorry. It just said, for example, that thing turns into this. Do you see how it happened? Wasn't that fun? Yes. Okay. Had to be fun. Okay. Now, the next question is, what if you had been integrating that? Okay? I think that we can integrate this part okay, right? What would that be? X plus 1. That's the value x plus 1. Okay. Now, how about this one? It would have been nice, the derivative of the denominator would be 2x plus 1. If you'd have had, all you have is the x up there. So if you let u be this, du would be 2x plus 1. That's going to be awkward trying to get that to work. I don't know if you can. Okay? Maybe you can. We'll leave that alone for now. Okay? Well, we'll leave them all alone. They're not doing that one yet. I thought they were going to get to it here, but it says you may need to use trigonometric substitution to integrate these terms, the ones up above. In particular, the following result may be useful. And it says go back to 7.3 and look at it. And here's what the following result is. I'm going to go and erase this. I sure hope I don't need it anymore, because I want to blow this up. Okay. All right. If you have a form that is like this, and looking above, that would have been neither of those last two terms, I don't think, okay? But if you had a form like this, you can do a trig substitution of let x equal a, the square root of a times the tangent of theta, remember? And we've done all that before. This is what the answer gives you, okay? If you had gone through and done all that, you get 1 over square root of a, inverse tangent of a over square root of a, x over square root of a, then you plus c. So that's just for future reference. If you get a form like this, that's what it turns out to. You could have looked it up in the table too. So, what we're going to do now is example 5. Okay? Now, example 5, part of it is here. We're going to do part of it here. The integral of 18 over x plus 3, thank you very much, they factored it for you already, times x squared plus 9. dx. Okay? Have they factored completely? Yeah or no? Yes, they have. Okay? Because this can't be factored any further. That's the sum of two perfect squares. There's no way to factor that. Not even with irrational numbers. Because if you try to, let's just do it this way. Set that equal to 0. That's what you usually do to factor, right? And then subtract 9 from both sides, you have x squared is equal to negative 9. Not ever going to happen. It's going to have i's in it. Complex numbers. We can't do that. That's irreducible. Okay? So, you tell me what, we'll start with this. In fact, here it is right here. I won't write it again. Here it is here. 18 over x plus 3 times x squared plus 9. Okay, what would you do next?
A1.
Okay.
Over x plus 3.
Okay. They just said a over x plus 3, but that's fine. Plus, second. Remember, you have to do this numerator 1 degree less than this. This is quadratic, so you do this linear. That's bx plus c over x squared plus 9. Okay, remember that. Remember, you always are going to have these. This is a linear term down here, so that's a constant up there. This is a quadratic here, so you have the linear numerator. Always include it all. Okay, so you've gotten that part done. What's your next step? Multiply by what? By that first denominator. X plus 3 times x squared plus 9. Okay? You multiply that by it. You multiply this by it. X plus 3 times x squared plus 9. And multiply this one by it. X plus 3 times x squared plus 9. Okay, what do you get on the left-hand side of the equal sign now? Just 18. Equal to, what do you get on the right-hand side, first term? Okay, he did A1. The book just does A, but it doesn't matter. Okay, A times x squared plus 9, right? Plus bx plus c times x plus 3. Okay. Now, what would you do next? Second?
Tons of letter numbers.
Okay, how do you do that? Thank you, I think I will do that, okay?
Let x equal -3.
All right, there's a good first start. Let x equal -3. Left-hand side becomes 18 equal. Second? 18a? Okay. Plus what? Plus what? Nothing, 0, because -3 makes that 0. So what is a equal to? A is equal to 1. Got it. All right. Then we do multiply what we got left. 18 on the left is equal to x squared plus 9. When a is equal to 1, that's just the left is x squared plus 9, right? Plus, that's for all this, bx squared 3bx plus cx, right? Plus 3c. Is that what you get? That's why you have a smiley face, right? Okay, never mind. Okay. Now let's go to town with this one. What's your maximum exponent on the right? Maximum exponent on the right.
3. C.
Second.
C.
Exponent. Yeah, 2, right? So let's do those terms. What's your x squared term on this side? 0 is equal to?
That's
1 plus b. So 0 is equal to 1 plus b. This was hard for us last time. What did that come up being? So b is equal to -1. A is equal to 1, b is equal to -1. Okay? Let's go to our linear term. What's the linear terms on the left? 0 on the right. 3b, but b is -1, so that'll be a -3 plus c, right? Were you writing that down? 0 is equal to -3 plus c. Is that what we said?
Yes.
Okay, what does that tell us?
C equals 3.
C equals 3. All right. Okay. I think we got them all now, don't we? Let's just check it. Why not? Okay. Let's do the constant term. What is it here? 18. What is it here? 9 plus
3.
9 is 18. Yes, it works. So we feel pretty confident we got the right numbers. Okay? We didn't have to do that, but I just thought it would be fun, wouldn't it? All right. So what I'm going to do, if I can get the eraser to come up, started to do something here, but I found out I didn't need to. So this will now be the integral of, okay, I need to do some erasing so you can see better because this is pretty crowded. I don't think I need any of this anymore. I want to hang on to what my constants are, but all this stuff is just in the way here. So let's get rid of it. And that, did I erase my D? Oh, I don't have a D. Okay, good. No, I didn't erase my D. You should console me. Oh, let's see, before I do that. Okay. All right. This thing here was what was in the integral, right? You see down here? So now we're going, sure hope that's an equal sign. I can't tell from here. Yeah, that is an equal sign. It's just really hard to see. So we're going to make this our integral and this our integral. Okay, what's your A? 1. So that's equal to integral of 1, or let's just call it dx over x plus 3. I think we can handle that one, right? Plus, what's your B? Okay, so let's put a minus there. You have to be careful with this now, okay, because you're leading off with the minus. Minus the integral of 1, it's a plus, I'm sorry, 1x, so that's just x, and it would have been plus 3, but we pulled the minus out, so that makes it a minus 3 over x squared plus 9 dx. All right. Now I was going to go through the gory stuff on the last one, and I thought, let's not. They're not going to do it. We got to go through it on this one. And it's not too bad. This is a much simpler problem. What's that first integral? Natural log of absolute value of x plus 3. Okay, got it. Now that second integral, note this. I'm going to split that into 2 integrals. Is that all right? That would be a minus integral of x over x squared plus 9, right? Dx. And then the other one would be a plus 3, the integral of 3 over x squared plus 9 dx. Right? You okay with it? Okay. It's a minus in front of both of those. So now I'm regretting I even did that. I'm going to do the minus with this one and the minus and minus with the plus of that. Is that all right? Okay. Yeah, I just do it to confuse you. I mean, did I work? All right, good. Okay. I feel good about myself today. Okay. Mission accomplished. Okay. Now, can we do anything with that? Please say yes.
The x crossed out. What would divide out?
Oh no. This is that new math again. That you can divide things that are added, right? I always thought you could divide only things that are multiplied. Right? But this new math throws me off.
With dx.
Huh?
Isn't it being multiplied by dx?
Okay, I'm not talking about that. I'm talking about the denominator. You're saying cancel this with this?
Yeah.
No, is it multiplied by 9? No, it's added to 9. So no, you can't do that. You can only divide out things that are factored out. In other words, multiplied. So no, don't even try it. Don't even try it. Okay? So what might we do to that? Let you. Okay. Let me what? Okay.
Make u equals
X squared plus 9. Then
du equals 2x dx.
dx. Very good. We don't have a 2x dx. We have an x dx. So what might we do? Divide by 2. So du over 2 is x dx. So this first integral here is going to be a minus the integral of, minus 1/2, because we're going to take that 1/2 out front. The x dx is your du, once you pulled out the other, and this is over u. Right? And can we do that? And what would that be?
Would it be u to the negative 2 over 2?
Okay. U to the negative 2 over 2. Okay, let's see. If we take a derivative of this, this will be minus 2 times 2, that would be a minus 2 times 1/2 would be a minus 1 u to the second derivative. You drop that by 2 by 1, that would be a minus 3. That's not quite the same as that. Didn't we do something very similar to it right up there? Oh, yeah, that's a log. Okay. So no. Let's not do this. This would be a minus 1/2 log u. Very good. Okay. But what's u? Okay. It would be minus 1/2 log of x squared plus 9. And guess what? I forgot to put my absolute value bars, didn't I? Bad?
Not really.
Why?
Because it's already positive.
Always positive. Yeah, x squared is always positive. 9's always positive. Yeah. No problem. You don't need absolute value bars from that. Now the question is whether you want to make it minus log of x squared plus 9 to the 1/2, or plus log of x squared plus 9 to the minus 1/2, or leave it alone. I don't care. Okay, those are all legitimate forms. So we got that one done. Okay, so let's do that here. I'll just write it as we did. Minus 1/2 natural log of x squared plus 9. Okay, without absolute value bars. Now we got this last one here. Plus 3, the integral of 3 over x squared plus 9. Will it be all right if I do a flashback? How about this one? It looks pretty similar, doesn't it? So if A was equal to 9, that would be exactly that. With a 3 out front, right? So that'd be a 1/3 inverse tangent x over 3 plus c, right? So let's drag that forward, and that would be a plus 3, right? But we had a 1/3, right? This had a 1/3, this had a 3, so that disappears. Inverse tangent of x over 3. And now I'll put my plus c. All right, let's see how close they got it. Here we go, at the bottom of the page. Log of absolute value x plus 3 minus 1/2 log of x squared plus 9 in parentheses, look at them, plus inverse tangent of x over 3 plus c. They left off the parentheses after the inverse tangent, but otherwise they got it perfectly right. I can just imagine a web assignment saying, no, you have wrong answer because you don't need parentheses there. Yeah. No, I'm not going to even go there. All right. So that was that one. That was the A part. Okay. Let's see if we can do the B part of that one. I'm going to clear all this. We got that answer. Who cares anymore, right? Okay. Let's go to the B part. Let's do the integral of 18. This looks pretty familiar, doesn't it? X plus 3. That looks pretty familiar. X squared minus 9 dx. Almost the same problem, isn't it? What's different? Oh, you can factor that x squared minus 9. You couldn't do the x squared plus 9. What does that factor as? Say again? Times minus 3. Okay. All right. But that then gives us the integral of 18. I'm going to put my dx here. It just is in the way over there. Of x plus 3 squared times x minus 3. Right? So where would you proceed with this one? 18 over x plus 3 squared times x minus 3 equal what? A over x minus 3 b over x plus 3 plus c over x plus 3 squared. Very good. All right. I like it. Now what? On the left, right? X plus 3 squared times x minus 3. Multiply this by x plus 3 squared times x minus 3. Multiply this by x plus 3 squared times x minus 3. multiply that by x plus 3 squared times x minus 3. Okay. Left-hand side's easy. All the denominator goes away, leaving us with 18. Okay, I've been there, done that. Okay? Over here, what happens? X minus 3 goes away, and that leaves you with a times x plus 3. I put the square inside the parentheses. It should be outside the parentheses. Sorry about that. I don't know what was going on there. Okay. Squared plus. Okay. You wipe out one of the x plus 3's, but not both. B times x plus 3 times x minus 3. Right? Plus. Yeah, the x plus 3 squared. Both go out, and that leaves you just an x minus 3. All right. Now what? Let x equal negative 3. Okay. What's the left-hand side become? 18. No x is there. And when x equals negative 3, that becomes a 0. When x equals negative 3, that becomes a 0. When x equals negative 3, this becomes a? Second? Negative 6c. Right? Is that what you said? Thought so. Okay. So what does that tell us? Negative 3. C is equal to negative 3. Okay, one down. Let's x equal plus 3. Okay, what's the left-hand side become? 18 is equal to? Second? 36a. All right? And that's all, folks. That's all, folks. Okay? So what does this imply? A is equal to 1/2. All right. Well, we still got B to go. And nowhere to get there. Okay? So, what we have to do now, unfortunately, is multiply things out. And this will be a times x squared plus 6x plus 9. Did I do that right? Except my a is 1/2, so not even let's mess with a's anymore. Let's just put a 1/2 there. Okay? Plus, now b we don't know, so we have to put that. But we do know what that product is. What is it? X squared and minus 9. Right? Oh yeah. Okay. And this one will be at minus 3 times x minus 3. Right? Because you see with minus 3. Wasn't it? Okay. Okay. Now we start a mess. But guess what? The mess is pretty easy to begin with, I think. This tells us what is our, let's start with the square term. Well, this is still equal to 18. I just didn't write it down here, okay? So, what's your square term on this side? 0 is equal to 1/2 what you have here is 0 is equal to 1/2 plus b. So what does that tell you? B is equal to -1/2. And you don't have to do anything else. None of the rest of that matters. You got your B. You could check it if you wanted to. I know Bailey wanted to check it. Yeah. Okay. You could check and see if the other things come out, but I bet they do. I'll let you do it. I'll leave that to the student. Okay, that's what they always say in books, don't they? So now we got our A, our B, and our C. So what we're going to do here, yuck, I wish I had more room. So I'm going to erase this now, and that, and that, and that, and that, and that, and that, and this, and this, and that, and that, and that, and that, and that, and that. You ever watch that old guy that teaches art on? Yeah. And you do this, and then do this, and that's what I was doing. Okay. I don't need that anymore. I don't need this anymore. That's all I need. Okay. And I probably don't need that anymore. Okay. So, what we have now is our integral. I'm going to write it down again, I think. The integral of 18 over x plus 3 times x squared minus 9 dx is now equal to our a, which was 1/2. So I'm going to put the 1/2 out front, the integral of dx over x minus 3. Right? That's this part right here. Negative 1/2. A was 1/2 over x. Pull the 1/2 outside the integral and just put d. That's the dx, by the way, in case you didn't recognize it. You're making fun of me, aren't you? You're laughing at me, okay? That's probably not a lot better. Okay. Plus, except the b is negative, so we're going to do a negative 1/2 the integral of dx over x plus 3. Right? And then we have a minus 3, that's our c, times the integral of dx over x plus 3 squared. Okay. Isn't that what our integral has become? Did you follow that? I know I was doing too much of the talking. I'm afraid maybe the thinking too, but hopefully not, right? Y'all were thinking, weren't you? You were checking to make sure I got it right. I think we'll work from here. May need to erase more later. So what's this equal to? 1/2? What? That first integral. Say again? Natural log of absolute value of x minus 3. Minus 1/2 natural log of absolute value x plus 3. Uh-oh. What's that last one? 3. Say again? I can't hear you. Okay. Let me erase some, if that's okay, because I don't think I need this stuff anymore. I just used it, so I don't think I need it anymore. I may even erase this, because I'm sick and tired of looking at it. Okay. And I don't think I need my b's equal to negative 1/2. Yeah. Okay. So let's, for right now, just focus on this one. I'm going to write it over here. The integral of dx over x plus 3 squared. How would you approach that? Help me help.
Still the same problem.
It's the third part of that same problem. Part of the third part of the same problem.
Let u equals x plus 3.
Ah, that sounds like a capital idea. Let u equal x plus 3. Is that what you said? Then?
Then du equals x squared dx.
Oh, you were going so well.
2x.
Oh.
I'm tripping too. Equals dx.
dx, all right. Back together. So yeah. All right. Now, what does that integral become now with the u substitution? du over u squared, which I may choose to write as the integral of u to the minus 2 du. Does that integrate? How?
U to the -3 over 3. -1.
All right.
Over -1, so it makes it negative.
Put minus on the outside. Okay. And then we just go on and plug in what? So this last would be minus 3 times the u was x plus 3. Oh, okay. You had a minus 3, but then you got a minus, so that's going to wind up being a plus 3 over x plus 3. Because your u to the minus 1 is down there. And one other thing. Plus 3. All right, let's see how they got it. They got 1/2 the log of absolute value x minus 3 minus 1/2 the log of absolute value x plus 3 plus 3. They put 3 times x plus 3 to the minus 1. I put it over x plus 3. Same thing, plus c. They game. Done. Any questions? These can take a while, huh? But they're worth it. Okay? We'll begin next time with example 6. Sorry this is taking longer than I wanted it to. Did I, by chance, give you all your tests last time? I don't think so.
Chapter 7?
Yeah, chapter 7. No, we don't need it yet. We got to finish 7.5. I was thinking we got to do 7.5 and 7.6. Sorry about that. 7.6 will go pretty easily. Improper integrals I'll talk with you about it in case you ever need them, but we're not going to do too much with it. And 7.8, I'll talk about it, but we won't do too much with that. And 7.9 is numerical integration. Yeah, we got a little ways to go, so not yet. Okay. Y'all still working on test 1, though, huh?
I am.
You are. Okay, yeah. All right. Good deal.
I'm done with the essay.
Oh, good. He had to rub that in, didn't he? Okay. All right. Nobody's.
I got the test right here.
Good.
I'm
I've got.
number 2.
Okay.
I'm on number 3.
All right. Making great progress.